Alright, so today we're going to go over 1.3 properties of real numbers. This is my first time recording with this tablet and microphone, so hopefully everything goes well. Alright, so learning properties of equality. There are several properties of equality that apply to the addition and multiplication of real numbers. So they're in this table below. So first we have the reflexive property. So that's any quantity is equal to itself. So they give an example with symbols. So for any number A equals A. So some examples that you could see in real life are 3 equals 3, and that 9 plus 2 equals 9 plus 2. The symmetric property is if one quantity equals the second quantity, then the second quantity equals the first. So for any numbers A and B, if A equals B, then B equals A. So the symmetric property allows you to flip around the equal sign. So an example is 7 equals 3 plus 4, then 3 plus 4 equals 7. So that's showing the symmetric property. The third one here is the transitive property. So it says if one quantity equals a second quantity, and the second quantity equals a third quantity, then the first quantity equals the third quantity. So it says for any real numbers A, B, and C, if A equals B and B equals C, then A equals C. So it's where the middle part, so like the last thing in the first one, so B, repeats, then you can take the first equal to the third. Okay, so it has to be that second thing repeats in both of those. So it says if 5 plus 1 equals 2 plus 4, and 2 plus 4 equals 6, then 1 plus 5 equals 6. So that 2 plus 4 repeated. So then they took the first thing of 5 plus 1 and set equal to the third thing of 6. So some examples they have here are identify the properties of equality used to justify each statement. Explain your reasoning. So it says if 13 plus 25 equals 38. So I will let 13 plus 25 be A, and I will let 38 be B. It says then 38, which I said was B, equals 13 plus 25, which I said was A. So if we look at the three properties that we had, it actually matches up with the symmetric property. So we would say it's the symmetric property of equality. B says y plus 4, which I'll let be A, equals y plus 4, which I called A. So it has something equal to itself. So that would make this the reflexive property of equality. So you're just trying to see which one it matches up with. So if we go to the next page, it's the same thing here at the first part. We're just going to be seeing which one it matches up with. So we'll let this first one of A plus 7 be A, and it says equals 22 plus 7, I called that A. So this one is also the reflexive property of equality. And we have to specify of equality since it has an equal sign, because eventually we'll have a different symbol that we have to include. So part B says if 36, so A, equals 17 plus 19, so B, Then 17 plus 19, which I said was B, equals 36, which is A. So they flipped it, so this is the symmetric property of equality. So now we can go ahead down here to example 2. So it says interpret properties of equality. So if the amount of sugar in a recipe is equal to the amount of flour plus 2 tablespoons, and the amount of flour plus 2 tablespoons is equal to the amount of milk, then the amount of sugar is equal to the amount of milk. Okay, so we're going to say what things equal here. So we had sugar, which I'll call A, equals flour plus 2 tablespoons, which I'll let be B. Then it said the amount of flour plus 2 tablespoons. So flour plus 2 tablespoons, which I said was B, equals milk. That's a new thing, so I'll call it C. So then it says, then the amount of sugar, which I called A, equals the amount of milk, which I called C. So we had A equals B, B equals C, A equals C. So that fits our transitive property. So the next part says the statement is an example of what property of equality, and we'd say transitive. So it's important that this B part repeats, and then you take the first equals the third to get that last statement. So we kind of have the same thing here. So it says the weight of a bag of oranges plus 13 ounces is equal to 5 pounds. So we would let oranges plus 13 ounces be A, is equal to 5 pounds, which is B. So it says which quantity is equivalent to 5 pounds, which is B. So they gave us A equals B. So the only statement that we could write from here, since it starts out with B, is that B equals A. So which quantity is equivalent to 5 pounds? We would say the weight of a bag of oranges plus 13 ounces. And since we flipped it, because we had A equals B, B equals A, that is showing our symmetric property of equality. Okay. So then example 3 says use properties of equality. Use the given property of equality to complete the statement. So it says y minus 21 equals blank, but reflexive. Reflexive was that A equals A, so you would just repeat it. So this would be y minus 21. B says if A plus 11, so A, equals 9 plus 26, so B, and 9 plus 26, which was B, equals Z, so C, use the transitive. So it repeated our A, and based off transitive, since this B repeats here, we would set A equal to C, so in that blank would go Z. So we can go ahead and go to the next page here. So for this one, it's talking about identities and inverses. So the sum of any number, a and 0, is equal to a. Thus 0 is called the additive identity. If the sum of two numbers is equal to the additive identity, like 4 plus negative 4 equals 0, then the two numbers are additive inverses. So if you're adding 0, it's the additive identity. If you add and get 0, it's the additive inverse. So that's kind of what they're representing here in this table. So for the additive identity property, for any real number a, the sum of a and 0 is a. So if you add 0 to something, you'll get that original thing. A real number and its opposite are additive inverses of each other. So 2 and negative 2, 7 minus 7. So those types of things that get you 0 are additive inverses. So the product of any number a and 1 is equal to a. Thus 1 is the multiplicative identity. The property of any number a and 0 is equal to 0. This is called the multiplicative property of 0. So if you multiply something by 1, you'll get that something back, which is multiplicative identity. If you multiply something by 0, you'll always get 0. So that's the multiplicative property of 0. And then two numbers with a product of 1 are called multiplicative inverses or reciprocals. So I'll show you an example when we get to there in the table. So multiplicative identity property. For any real number a, the product of a and 1 is a. For the multiplicative property of 0, for any real number a, the product of a and 0 is 0. So multiplicative identity is mainly going to be when you have something that you can write as a fraction multiplied by that thing flipped. So they give a good example of actually using a fraction. So another type of example that they don't show here, which is probably the most missed example, is if I had 8. 8 is a whole number, so technically it's over 1. So its multiplicative inverse or reciprocal would be if you flipped it, so 1/8. So if I multiply those, I'd get 1. So it's important to know that even with whole numbers, you can turn them into a fraction by writing it over 1. So when you flip it, 1 is the numerator. So here, they want us to go ahead and evaluate some math problems. So it says evaluate 4 minus 2 squared plus 8 times 2, or 8 times 2. So this is where you use order of operations. So PEMDAS, forgot the D there. So evaluate, so there are no parentheses, so I move to exponents. So I'd have 4 minus 2 squared is 4 plus 8 times 2. Next would be multiplication division from left to right. So the only multiplication they have here is 8 times 2. Well, 8 times 2 is 16. Now we'll add subtract left to right. So 4 minus 4 is 0. We have plus 16. And 0 plus 16 is 16. So here, this showed us using the additive identity in this step. Because we added 0 and got that thing back. So it's the same thing here. they want us to evaluate. So based off order of operations, I would leave 13 and then do 2 squared, which is 4, and then we have plus 0. Well, 13 and 4 is 17. I still have plus 0, which will get me 17. So once again, we use that additive inverse in this step. Or not additive inverse, additive identity. Now, I will say back up here, when we did that 4 minus 4, that was the additive inverse. So in that problem, we actually used both of them. So you could have problems in your assignment where it asks you to identify where the additive inverse happens, where the additive identity happens. So the 4 minus 4 getting us 0 is additive inverse, where when I actually add 0, it's additive identity. So example 5 wants to use multiplication. So if I look at that first one, we have 3 times 2, or 3 over 2 times 2 over 3. So they took the fraction, they flipped it, which means they're using our multiplicative inverse. Which when we do that, we're going to get 1. So this turns into 1 times 7. Well, when I'm multiplying by 1, that's multiplicative identity. Which means when I multiply by 1, I just get that number back. So 7 would be our final answer. So here it says identify the property used in each step. So we have 4 times 1, that becomes 4. So multiplying by 1 is our multiplicative identity. Okay. Then they did the 4 plus 0. Well, that would be additive identity. Next, they did the 4 minus 4 to get 0. So that's additive inverse. Which got them 0 plus 3, so they're adding 0 again, which makes it go back to additive identity. So this example didn't have any multiplicative inverse because it didn't have us multiply by a reciprocal. So we'll go ahead to this next page. So it's going to be kind of the same idea here. It wants us to go through, simplify this. So we'll do PEMDAS, even though some people right away might be able to see what the answer is, but we'll just go through our order of operations. So we have to focus on this grouping first. So if I look in there, the first thing I have to do is multiplication. So I have 4 minus 3 times 2 is 6, and then we have plus 7. And then times 0 is still outside. So we do 4 minus 6, which is negative 2. So I have negative 2 plus 7, still times 0. Negative 2 plus 7 is 5. And then we have times 0, which the multiplicative property of 0 says if you multiply by 0, it is 0. So technically you could have seen that it's going to turn out to be 0 in that very first step, since everything else is in those brackets. So since it's being multiplied by 0, that whole bracket, our final answer has to be 0. So this next one also wants us to find, or to evaluate this, and it does have us use 0 as well. So first I would do 13 minus 1, which is 12. Then I have times 0 plus 3/4 times 4/3. So now we can do our multiplication left to right. So 12 times 0 is 0 by our multiplicative property of 0. Then we have 3/4 times 4/3. So if you notice, they flip it, so that's multiplicative inverse, which gets you 1. So now we're at additive identity, because we have 0 plus 1, which is 1. The other type of properties we could have, which you guys have talked about in younger grades, are commutative and associative property. So an easy way to find the sum or product of numbers is to group or associate the numbers using the associative property. For addition and multiplication of real numbers, the order does not change their sum or product. This is called the commutative property. So once again, they have some examples here in this table, which will kind of help us see what it looks like. So associative property. The way you group 3 or more numbers when adding or multiplying does not change their sum or product. For any numbers a, b, and c, a plus b in parentheses plus c equals a plus b plus c in parentheses. So it's saying with associative property, you can change what your parentheses is around, and you'll still get the same answer. So they show that here down in examples. So they have 2 plus 9 in parentheses plus 4, which would be 15. Then they have 2 plus, and then in parentheses 9 plus 4. That also ends up being 15. So you get 15 either way, which is what allows you to switch those parentheses around. The same thing can happen with multiplication. Commutative property is when you can add or subtract numbers, the order doesn't matter. So if I look at addition here, they have 8 plus 12 is the same as 12 plus 8. So I'm allowed to flip things around those addition signs. Same with multiplication. 4 times 9 is the same as 9 times 4. So those are those two properties. Okay. So they have a word problem here where they want us to apply it, and then a check problem. So it says, Jalen wants to add up how much money he spent on gasoline in July. He grabs the 4 receipts he has for July and writes the expression that represents the total amount he spent. Evaluate the expression to determine how much money Jalen spent on gasoline in July. So it wants us to go through, and he has his 4 receipts. So we're going to go ahead and write it. So he has a total of $34.50 for this first one. For the second one, so we would add, because we're trying to get a total, it's $32.50. Then he has $23.25 and $31.75. Now, if I'm looking at it, how these end, those two ended with 50, and these add with 25 and 75, I would want to group them. So the associative property allows me to put in parentheses. Oops, I actually hit my eraser. Okay, got it back. Allows me to add parentheses around the first two things and then around the last two. So if I take 34.5 plus 32.5, that gets me 67.00 because it's money. Then if I add the second set of parentheses I put in by associative property, those will get me $55. Now this makes it a little bit nicer because both of my amounts of money end in zeros instead of having some change on there. So if I take 67 plus 55, that's 122. And then this is money, so I put 00 after my decimal, and then I can put my money sign. So I was able to group them based off the cents so that we can make it a nice number when we go to solve it. So here, they want us to determine what property was used. So when I look at this first thing, and then I go to the second, the part that changes is right here. So they added in parentheses. So that would be the associative property. Now, technically, when you guys go to identify this in the future, you'll want to say associative property of addition to specify which operation it's happening to. Okay. So then they added it here and they got 90. And then when I look at the next step, they took that 90 and they put it in the back and they brought 26 forward. So they flipped things around that addition sign. So that's when they started using the commutative property of addition. Because once again, this was addition and not multiplication. So then they just finished simplifying it to get a final answer. Okay. So we're almost done with the 1.3 notes. So if we go and turn our page one more time, we'll be on this last set. Here, it's going to be the same type of idea. So using the commutative property. So looking at this, I can already tell, looking at the first and last, that I would want those near each other. So my commutative property allows me to flip this around. So I could say 5/6 times 6/5 times 9. Well, since these are reciprocals, I know they'll get 1. So I have 1 times 9, which is the multiplicative identity. So I get the answer of 9. So that's kind of nice when we can switch things around like that so that we can have easier things. So here it says Josephina needs to evaluate 7/3 times 2 times 3. She wants to use the commutative property to more easily evaluate the expression. What should she do first? So if I look at this, we have a fraction. This denominator is a 3. Based off what we know about multiplication, this 3 over here is over 1. If we have the same number in the denominator and the numerator, those would cancel out. So the thing she would want to do first is the 7/3 times 3, because those 3's would cancel, leaving her with 7, making this problem a lot easier. So the correct answer on what she should do first is 7/3 times 3. Last two examples here. So it says evaluate using the associative and commutative properties. Jade buys groceries once each week, and she wants to calculate how much she spent on groceries over a 4-week period. Evaluate the expression to find how much Jade spent at the grocery store. So we have a total here, so we're going to go ahead and adding all these up. So I have 32 plus 27 plus 28 plus 33. Now, based off how these numbers end with 2, 7, 8, and 3, I would want the 2 and 8 near each other and the 3 and 7 near each other because I know those add to 10. So I can use my commutative property to rewrite this as 32 plus 28 plus 27 plus 33. So that's my commutative property. And then just remember in the future, oh, I hit my eraser again. You'll have to specify it's definitely by addition. Okay. So now we can add associative property so that we're grouping so that we do those groups first. And we'll have to specify of addition. So I would put 32 plus 28 in parentheses, and then 27 plus 33 in parentheses. So 32 and 28 is 60. 27 and 33 is 60. And then 60 plus 60 gets us a final answer of 120. So it's just nice to be able to use these properties to make this math a little bit simpler and faster to do in our heads. So here they're going to have us do it with multiplication. So we're going to go ahead. I would rewrite it so that my fractions are near each other using our commutative property. So 5 9ths times 9 5ths times 9 times 4. And like I said, that's our commutative property. And this time it's a multiplication. Then we're going to go ahead and actually multiply these. So if I do that, it gets me 1. And I have times 9 times 4. So 1 times 9 is 9. 9 times 4 is 36. Getting us a final answer of 36. So those are our 1.3 notes.